Okay, in this video, we are going to just introduce the waves topic. We're going to look at what a wave is. We're going to look at the two categories of waves. And we are going to look at how waves are actually produced. So we'll start with this. We'll start with what is a wave. So the definition of a wave is an oscillation or vibration. So I'm going to write the word oscillation. It's a very key word. Oscillation. It means a movement in a backwards and forwards rhythm. So it's an oscillation that transfers energy from one place to another, but the key thing is that matter isn't transferred. So for instance, we have A and we have B, and we want to transfer some energy to A to B. A wave will do that for us without taking A over to B. So I'll give you an example. Here's a daft example with a Mexican wave at a football match. So we're going to start off, and these are all the people that are sat in their seats at the football match. Okay, so we've got, we're going to say that this is the section A of the crowd, and this is section B in the crowd. Now, A is going to make B do something, but without going over there and telling B to do it. And the way that this would happen is this. So we're going to do a Mexican wave. So what's going to happen is A is going to stand up. So I'm going to represent him standing up by just sticking some legs on him. All right, so A is stood up. We'll put the A above him, all right, and we'll put the B so I can fit the legs in. So A is stood up. Now the next person next to A knows, oh, A stood up. Well, I'm going to stand up too. They stand up. So we're now getting the energy is starting to be transferred. It's got to here so far. Then the next person goes, oh, well, I'll stand up as well. So they get to there, and as you can see, the energy just moves along. It's being transferred, and finally, B goes, oh, everyone else is doing it, I'll stand up. So the energy is moved from A to B, but the key thing is A did not actually move B. So no matter was transferred. Let's have a look at the two types of waves. So type 1 is mechanical. So mechanical is a type of wave. Now in a mechanical wave, something has to travel through a substance. So we call this a medium. So right through a medium. So a medium is just an area of particles. It could be a solid, it could be a liquid, or it could be a gas. So it's just transferring through a solid, liquid, or gas. So I'll give you an example. So let's say I have a trough of water. Now at the moment in my trough of water, we've got a 0 point. The 0 point is just the level of water. It's not moving. It is still, because there's no vibration in this water. It's just totally flat. And I'm going to have a positive part and a negative part. And the reason I'm doing this is for when we show graphs later on and be able to label waves, this will make more sense. So I'm going to get an object. I'm going to put it into my trough of water. So let's say a block of wood. And I'm going to start to oscillate my block of wood. I'm going to push my block of wood down into the water, and that's going to create a part of the wave that does that. It goes down. And then I'm going to lift my wave up, back out of the water, and then that's going to create a bit of wave that does that. So far we've gone down and up. And if I continue to do that, it'll go down again and up again and down again and up again. And we'll produce a wave. So this is just a wave pattern. And all that's happened is I have moved an area here. So this is area A. And it has transferred energy to area B. But I have only moved the matter here. I have only moved these particles in this particular area where the wood is. However, the energy has been transferred to B. Okay, so in terms of mechanical waves, there are a couple of examples. So the one I've just shown you there is of water. So waterways, I'm sure you're all familiar with waterways. Another example of a mechanical wave might be sound. Now in sound, I'll draw you another picture of sound. Let's say we have I'm going to draw a very interesting drawing of a mouth here. There we go. All right, so we've got a mouth. We can see it's a mouth because we've got some teeth in it. Now, this person is shouting, and he's going to shout, and he's trying to get the attention of someone over here. We're going to represent just with their ear. So here is a person over here. Now, as this person shouts, this is the wave moving out, and the information can travel from this person's mouth all the way into that person's eardrum, and that person will hear them. This was place A, this is part B, and you can see that the matter, so this same particles here in this matter, so the particles of air that were here have not gone from this person into this person's ear, because there could be lots of people listening to this one person, and so that one part of the air can't have gone to all the different ears. It can't. So what's happened is that that's sort of hit into another particle, which is hit to another particle, another one, and spread out. So the matter hasn't been transferred, but the energy has. So that is sound. Another one that we could have is earthquakes. So earthquake is exactly the same thing, but I'm not going to try drawing an earthquake. The other type of wave, the other category of wave, is EM. And EM stands for electromagnetic. Okay, EM, electromagnetic. And what an electromagnetic wave is basically there has to be a charged particle. So we get a charged particle. So I'm going to draw an electron. So an electron has a negative charge, but we could easily just have a proton have a positive charge. Now, when an electron oscillates, so it moves up and down, it does exactly the same thing as when I was moving my block of wood on the water. We get a wave produced that is like this. So this is the positive, it's the negative. So this is the electric part of the wave. So this is the electrical. So it's this up and down here. This is the electrical. So when the electron is moving up, we get a positive electrical, and then down we get a negative electrical. I'm going to draw my area of no disturbance here. But when an electrical charge moves, this is something that you'll look at in the next topic in magnetism, electromagnetism. When a charged particle oscillates up and down, as well as there being an electrical component, there is actually a magnetic component. Now this is going to be really hard to draw because it happens at 90 degrees. So let's say that this is 90 degrees. Hard to do in 2 dimensions, this. So that's going up and down, but also there's going to be a magnetic part that is going out at 90 degrees. So that's why it's called electromagnetic, because it's got an electrical part, and at 90 degrees it's got a magnetic part. So you don't need to go into too much detail about that, and don't worry too much, but it's good that you have a brief overview of why it's called electromagnetic. So it's a charged particle oscillating. Now, the key thing is as to why this is different to a mechanical wave is that it doesn't need to travel through a medium. So it does not need a medium. That's not to say that it won't travel through a medium. It can. So an electromagnetic wave can go through a solid, liquid, or a gas. But it can also travel through what we call a vacuum, an area where there is no particles at all. So here's an example. So we've got this big thing in the sky. We've got the sun. Okay, and we live on a little planet over here called the Earth. So let's put a little person. They're standing on the Earth here. All right. Now we're gonna put a hat on because it's hot. Your little sun hat. Now, this sun gives out waves. It gives out these electromagnetic waves. I'm going to draw both parts in. And it gives out all different kinds. It gives out some that have got sort of long wavelengths. It's some that gives out very, very short wavelengths, and some that have got even longer. But it gives out loads in all directions. But we can detect these because this person who is standing on the earth would be able to see the sun. So that's a light wave. So they can see a light wave. And this person also might get quite hot if they're stood directly in the sun. So that would be an infrared wave. I'm just going to write IR. We'll do EM waves in more detail in another video. But they would feel the heat of the sun. So this whole area here between the sun and the person is space. And space is what we call a vacuum. It contains no particles. So there's no medium, there's no particles there. So the sun isn't knocking one particle to the next particle into the next particle like with a mechanical wave. There's nothing happening at all in terms of movement of particles and movement of matter. EM waves are just able to travel through a vacuum, and that's the key difference. So mechanical waves have to travel through a medium, a solid, liquid or a gas, whereas an electromagnetic wave does not need to travel through a medium. Okay, so that's the brief overview of this video. I'd like you to have a go at the questions which I'm going to attach to the end of the video.